Hello, Assalamualaikum and good morning everyone. I hope you are just fine. How do you do today? So this is our 8 physics online classes for Smk Bagan Jaya for SPM revision 2020. So I hope everyone are fine and already took your breakfast as we are about to begin very soon. Okay. Before that, please prepare with your module and your calculator as well. And I hope you have tried this module, which I sent to you earlier in your WhatsApp and Telegram group. Okay. So let's go to the module if you are ready. So today we are going to discuss module 1. Okay, for this new revision module, I have prepared 4 sets of module for you. So for today, we try to finish with the first module. Okay, so can you hear me clearly? If you can hear me clearly, can you please respond in the live chat section? You can type there, clear. Okay. Okay, so if you are ready, let us begin with my slide. Okay, so in this module 1 altogether, we have 10 questions. Okay, multiple topics. Okay, variety topics we have there. And the questions are on both structures and essay. Okay. Okay, thank you for responding. Okay, so let's move. Let's begin our revision with question 1. Okay, so class, in question 1, you are given diagram 1.1. All right, it shows the velocity time graph for Abu, who is practicing in a 100-meter race. He made 3 trial run, K, L, and M. So Abu runs for 100 meter and he did it for 3 times. And diagram 1.1 shows his motion. Okay, you can see in this diagram a graph of velocity against time for Abu. This is for the first trial K, second trial M, and his third trial M. Okay, so the first question, what is the meaning of velocity? Okay, definition for velocity. What velocity is? For those who have tried, can you share your answer? What is the meaning of velocity? Who remember what velocity refers to? Okay, yes. So velocity is rate of change of displacement. Rate of change of displacement. Okay, then B1. In which trial did Abu accelerate the most? Which one? The first trial K, second trial L, or the third trial M? Which one? Abu accelerate the most. So what do you say? K, L, or M? Okay, yes, very well. The first answer is rate of change of displacement. Okay, so Vinci say trial K. Okay. Yes, Dylan also say K, William say K. Yes, the answer is trial K. Okay, trial K. Okay, very good. Okay, it's trial K. Okay, now next questions. Okay, look at the next slide. Okay, now question 2. Okay, give a reason for your answer in B1. Why do you say he's having highest velocity at trial K or highest acceleration at trial K? Why do you say he accelerate the most at trial K? Why? K is the highest acceleration. Why do you say that? Okay, Vinci, why do you say it's K? Hui Liang, Dylan, or Jinjie? This is because, yes, okay. If you look at this graph, a gradient K is the highest. Okay, K shows a highest gradient. Okay, remember when you are having a velocity time graph, when you're given velocity time graph, the acceleration is given by the gradient. Wei Liang say velocity is higher and time taken is shorter. Okay, that is not the good explanation. Yes, Vinci. The gradient which represent the acceleration of k is the steepest. You have to look at the gradient because the gradient represent the acceleration. So which a graph shows a highest gradient or a steepest gradient means that graph shows a highest acceleration. So the reason is gradient k is the highest. Okay, clear? Okay, now question 3. Abu's coach has suggested that he has to wear a smooth and fit attire to increase his velocity. So give one reason for this suggestion. So what is the purpose of wearing a smooth and fit attire when you are running? For what? So what is the reason for his coach suggestion? This is to, yes, very well. Okay, to reduce friction. Okay, to reduce friction, or you can say so that Abu will have a greater net force. Okay, or to reduce friction. To reduce air resistance, yes, true. Air resistance or to reduce friction. Yeah, reduce air resistance, William. Yes, okay. Okay, next we go to question C. Okay, now you're given diagram 1.2. Okay, diagram 1.2 is a velocity time graph for a toy car. Now we have a toy car. So based on this diagram, number 1, state the type of motion of the toy at region PQ and ST. Okay, so what happened to the toy car at region PQ? What can you say about the car's velocity or the acceleration? Okay, you can see PQ. It shows a straight horizontal line from 0 to 2 seconds. So what can you say about the motion of the toy car at this moment, PQ? Okay, yes. Okay. Okay, sorry, gradient as dekat ini you can ignore this. This is the answer for the previous questions. Okay, now we go to this. So what happened? Yes. Okay, so in PQ, the toy car has a uniform velocity, or you can say constant velocity. Yes, Yutong. Very good. Or you can mention about the acceleration, zero acceleration. Okay, so 3 answers are acceptable here. Uniform velocity, constant velocity, zero acceleration. Okay, the answer above you can ignore. This is the answer for the previous questions. Okay, how about ST? Okay, what happened to the toy car in region ST? Okay, ST is down here. Okay, what happened to the car at ST, region ST? Okay, anyone? Okay, so in region ST, yes, we say the toy car move, okay, in a uniform acceleration or velocity increase uniformly in opposite direction. Okay, or you can say now the car has a negative velocity. Negative velocity means it moves in the opposite direction, okay, from the previous motion. It is now moving in the opposite direction. It's not deceleration, Jinjie, because if you look from S, okay, initially the car moved from P to Q. Okay, first to second, it start with the velocity of 30 meter per second. Okay, the first to second, it move at a constant velocity, 30 meter per second. And then what happened in QR? In QR, you can see the car decelerate. Okay, the car decelerate until it stop at 3 seconds. So from 3 to 4 seconds, the car stop. Okay, the velocity is 0. And then it start moving again from S to T. So it start from 0 to 30 meter per second, but in the opposite direction. Okay, in the opposite direction. So that's why the graph is below the principal axis. Okay, below the below the x-axis. Are you clear that, Ginje? So it's not deceleration, it is an acceleration, but in the opposite direction. Okay, so this is for PQ and ST. Okay, are you clear? The motion in ST? Are you clear now? Again, it is not deceleration, but it is an acceleration, but in an opposite direction. Okay? Okay, now let's calculate the total displacement for the toy car. How far? Okay, the total displacement. Remember, displacement is a vector. Okay, it shows magnitude and direction. So how to find the total displacement of the toy car? When you are given a velocity time graph, how we can determine the displacement of the object from where? So we can find displacement by calculating the area under the graph. Okay, we calculate the area under the graph from 0 second up to 6 second. Okay, Wei Liang say 45 meter. Okay, let's check them together. Okay, in the first 3 second. Okay, in the first 3 second, the area is above. Okay, and then from 4 to 6 second, the area is below. Means the direction is opposite. So here you have to minus, okay, to find the total displacement. So how to find? Total displacement is given by total area under graph VT. Okay, so this is the area for the first motion. The first 3 seconds, we have a trapezium shape. Okay, from 0 to 3 seconds, it shows a trapezium shape. So this is how to find area for trapezium. Okay, half multiplied by the two side, 2 above is 2 plus 3, and then the height is 30 for trapezium. So here we minus. Why we minus? Because it shows the area below, mean opposite direction. If both are above, then you have to plus them. Okay, so below here we have a triangle. So this is the formula of area for triangle, half multiplied by base, which is 2, and multiplied by the height. Okay, the height is 30. So by this, the total displacement is 45 meter. Okay, very well, Wei Liang. Very good, 45 meter. Okay. Next. Okay, now D. Okay, in diagram 1.3, okay, now you're given a new diagram 1.3, you are asked to sketch the acceleration time graph for the motion of the toy car. So initially you are given a velocity time graph for you now to sketch an acceleration time graph. So how to sketch an acceleration time graph? So first you must know what is the acceleration in each region. So we have region PQ, QR, RS, and ST, as I show to you here. So in region PQ, what is the acceleration? Acceleration is 0. Why? Because the velocity is constant at 30. So you mark. You find the acceleration for each region first. Okay, and then in QR, what happened to the car? You can say, you can see obviously the car is now decelerate, velocity decrease. So this is the value for the deceleration, V minus U divided by T. Okay, V here is 0 at 3 seconds. Initial velocity at Q is 30. The time is 1. So here it decelerate at negative 30 meter per second squared. And then what happened in RS? Again, in RS, okay, the acceleration 0 because the velocity also 0. Okay, down here, the car accelerate. Okay, down here the car accelerate from 0 to 30 second in 2 second. So the acceleration is 15 meter per second square. So by this, now we can sketch the acceleration time graph. Okay, so in the first 2 second, okay, first 2 second acceleration is 0. Okay, so this is the line. Okay, then from 2 to 3 second, it decelerate. Okay, decelerate uniformly at negative 30 meter per second squared. Okay, so this is the line below. Show deceleration. Okay, and then in 3 to 4 second, okay, velocity is 0, acceleration also 0. So this is the line. Okay, and then from 4 to 6 second, what happened? The toy car accelerate at 15 meter per second square. Okay, now we join all this line. Okay, so this is the way we sketch our acceleration time graph. Okay. Who got it right for this question? D. 2 marks. Betul tak graf yang kamu lukis? Okay, so this is the way we sketch the acceleration time graph for the toy car. Okay. Any question on this question D? If you are clear, okay, we can move to the next part. Okay, again, this is how we sketch an acceleration time graph when you are given a velocity, a time graph of an object which is in motion. All right. Okay, if you have no further question, let us move to question 2. Okay, question 2 is on force and motion, chapter 2. Okay, diagram 2 shows a woman pull a box with a force of 800 Newton on a horizontal surface. And the force act at an angle of 37 degree from horizontal, from the floor. The box move at a distance of 4.5 meter and the frictional force between the box and the horizontal is neglected. So we neglect the frictional force. So the first question, what is the meaning of force? Okay, everyone, what is force? Can you type or share your answer? What is the meaning of force? Okay, what is force refers to? We have answered this question for so many times in class before. What is the meaning of force? Yes, very well. Okay, an act of push or pull. Action of pushing or pulling. Okay, pushing or pulling action. Or any action that can change the state of a motion also considered as a force. Okay, so the keyword is pushing or pulling. Push or pull. Okay, next. Okay, find, calculate the force that caused the box to move forward. Okay, so how to find the force that caused the box to move forward? First of all, you must understand when you are given a force of 800 Newton, okay, so this force can be resolved into its component. Okay, 800 Newton can be resolved into its two component of forces. They are Fx, which act horizontally. Another one is Fy, which act vertically. Okay, so which force causes this box to move forward? Fx or Fy? This one you must understand first. So you can see in this diagram, the box is moved forward horizontally. So it moved forward due to Fx. So this is the force we need to find. Ini yang kamu kena kira. Okay. Again, if you look at this diagram, diagram, okay, if I move this arrow, so how to find fx? Fx is given by f cos theta. Okay, fx is given by f cos theta. You do understand, right? How is this equation coming from? Why we can get fx equal to f cos theta? Okay, if you look at this slide, okay, uh, okay, if this arrow I shift to this side and this arrow of fy, okay, I bring it here. Okay, so now you can see that what happened in this drawing. You can see a complete triangle there. Okay, now you can see a complete triangle where this is fx, okay, and this is fy, and this is our force 800 Newton. So 800 Newton is now the hypotenuse, okay, the hypotenuse, and this is our angle theta 37 degree, which means fx is our adjacent side. Okay, fx is our adjacent side while fy is our opposite side, opposite to the angle. So what is the relationship between adjacent side fx and the force F? They will give you cos. Okay, the relationship is cos. So that's why we are writing here fx is equal to f cos theta. So to find the value, we do the substitution. F is 800 and cos theta is cos 37. So by this, fx is 638.91 Newton. Okay, can you check, is this answer correct? 638.91 Newton, 800 cos 37. Is it correct? 638.91 Newton. Okay, fx. Okay, second, you have to find the work done by the woman, okay, to move the box. How much work done by the woman in order to move the box? So how to find work done? What is the relationship between work done, force, and displacement of the box? How we relate them? So work done is given by force acting multiplied by displacement. Yes, very good. So the work done is given by the force applied, the force which causes the movement of the box. So Fx multiplied by S. How far the box have moved? It shows in this diagram 4.5 meter. So by this, the work done is 2,875.095. Okay, 2875.095 joule. Okay, here you have to be a bit careful. W is Fs, but which F we apply here, it's not the 800. Okay, but it is the component of forces Fx, which we have calculated earlier in the first part. Okay, because the box moved forward due to these forces of Fx. So down here to find the work, we use the force of Fx multiply with the displacement. Okay, don't put here 800 multiplied by 4.5. So you will get a wrong answer. Okay, that is a wrong understanding. Okay. Next, C, explanation, 3 marks. Explain what happened to the work done by the woman when the same force is applied. The force is still 800 Newton, but now the angle is reduced. The angle is now smaller than 37 degree. So what will happen to the work done? The work done greater or lower or no changes or how? What do you say? The force is still 800 Newton, but now the angle is reduced, less than 37 degree. So what happened to the amount of work done now? What can you say? What do you think? Increase, decrease, or no changes at all? Which one? So how we say, how we write the explanation. So what happened when the force is constant but the angle is less? Yes, very well, Jinje. The work done will be greater. Work done increase or work done greater. Why? This is because when the angle is smaller, so the forward force or the horizontal force will be higher. Yes, Swanzer, it will be increased. Very good. Okay, why? Because the horizontal force will be increases. Okay, so what is the connection between the angle and the force when the force, what is the connection between the angle and the force? So when the angle is small, the force will be bigger. The component force which is moved forward will be bigger. So bigger force mean bigger work done. Okay, so I hope you are clear. So this is how to get a 3 marks explanation. First, you say work done increase. Why? Because the forward force increase or the horizontal force increase. Why the horizontal force increase? Because smaller angle, so Fx increases or will be bigger. Okay. So that goes for questions 2. Okay, now we move to a new question, question 3. Okay, question 3 is on spring. Okay, spring, rubber band, and sponge are some example of material which show elasticity. So first question, what is the meaning of elasticity? Okay, class, what is elasticity? Elasticity, what does it mean? Okay, yes, very well. So elasticity refers to ability of a material to return. Okay, return to its original size or shape when the external force acting on it remove. Okay, this is the meaning of elasticity. So the material will go back, return to its original size or shape when the external force applied to it was removed. Okay, definition for elasticity. The keyword is return original size or shape, external force remove. All right. Okay, next, B. Okay, this is a long explanation. Explain how forces between the molecule cause elasticity. Okay, what happened to the molecule of an object which can cause the object to become an elastic material? So how to explain this? Actually, you can find the explanation in your module form 4 for this chapter, elasticity. I give you an example of a spring molecule. What happened inside the spring molecule when the spring is compressed or stretched? So how to say this? Number 1, you can mention there are 2 types of forces acting on a molecule or an atom of a substance. So what are those 2 forces? Who remember? Okay, 2 types of forces acting on atom or molecule of substance. So these 2 forces are called as force of attraction and force of repulsion. Okay, force of attraction and force of repulsion. Okay, next, what happened when the material is compressed? Okay, so what happened? The force of repulsion will restore back the molecule into equilibrium position. So when we apply external compression force to the material, so the force of repulsion of the molecule will replace back the molecule into equilibrium position. Okay. And And also the same thing happen when the material is stretched. Okay, when the material is stretched, so what happened? The force of attraction of the molecule will restore back, okay, into equilibrium position. Yes, Vinci, attraction force and repulsive force. Okay. So finally, what happened? So without external force, the net force is zero. So due to this action of repulsion and attraction, so all forces will be in equilibrium. So this is the reason why an object can become an elastic material. Okay, first you mentioned there are two types of forces, and then you name the two forces, and then you tell which forces acting when the material is compressed. So it is the force of repulsion, restore back the molecule into its equilibrium position. And then what happened when the material is stretched? So at that moment, the force of attraction act and restore back the molecule into equilibrium position. Okay, and last but not least, we say now all the net force is zero where the material or the molecule are in equilibrium position. All right. Okay, this is how we explain the elasticity of a material. All right. Okay, next we go to the long essay question. Question C. You are given table 3.1. It shows the characteristic of four type of spring, A, B, C, and D. And they give you the four characteristic of the spring. First characteristic is the spring constant. Okay. Second is the density. Third is the elastic limit. And fourth is the strength. Okay, it's the strength of the spring. So this spring is used to make a cradle. Okay, to make a cradle. Ali wants to make a cradle for his son of mass 4 kg. So explain the suitable characteristic of the spring to be used to make the cradle. And decide which spring is the most suitable to be used to make a cradle and give your reason. So you may Ali wants to make a cradle for his son, 4 kilogram son. So he has four options: A, B, C, or D. So you have to help him to choose which spring is the most suitable for him to make the cradle. Okay, so first what we do, as usual, we form a table of characteristic and explanation. Okay, form your table of characteristic and explanation. So these are all the characteristic discussed. Spring constant. Okay, you write them first. Density. Then we have elastic limit. Number 4 is the strength. And finally, which spring we choose. All right. So this is the proper table you can show. Again, these are the characteristic of the spring given on top. Okay. So what to say about the spring constant? Which one is the better choice? Low spring constant or high spring constant? How about the density? Low density or high density spring? Which one is a better choice? Elastic limit. Better to be high or better to be low? Okay, while the strength of the spring, better to be high or better to be low or enough to be medium? So which one did you say? Okay, talk about the first characteristic. What can you say about the spring constant? High or low, class? Spring constant, which one is a better choice? High or low? Okay, can you respond? What is your choice? Spring constant. You choose high or you choose a low spring constant? Okay, so we choose high or low? High or low? Anyone? Okay, so for the spring constant, yes, Wei Liang, we choose a spring with low. or small spring constant. Okay, it is low, bin C. Low spring constant. Why? Why choose a spring with a low spring constant? Hbin core, actually the answer is low. Okay, for those who are not from Bagan Jaya, actually you can download the question which I prepare for you in the description, in the video description. Okay, in a form of PDF file, so you can get it from there. So remember, we are trying to make a cradle here. So the cradle, it has to be oscillate. Okay, the cradle has to be oscillate. So we choose, in order to have this well oscillated cradle with a greater extension, so we choose a spring constant. We choose a spring with a low spring constant. Okay, low spring constant. Okay, why? So that we can have a high extension or high oscillation. So the cradle can oscillate easily. Okay, can oscillate easily. Remember, a spring with a low spring constant mean the spring is less stiff. Okay, so it can have a better oscillation. Okay, this is for the first characteristic. Okay, next, density. What can you say about the density of the spring? High or low density spring? High or low density? High or low density, everyone? So we can choose a spring with high or low density. You want the cradle to be heavy or you want the cradle to be light? This is the connection with the density. So we choose a cradle with small or low density. Okay, small or low density. Okay, small, low density. Yes. Why? Why the density has to be low? Why? Yes, so that it will be light. The cradle will be light, or you can say low mass, or to reduce the mass of the cradle. Okay, next, elastic limit. Okay, the elastic limit need to be high or need to be low? Okay, the elastic limit need to be high or need to be low? Elastic limit, high or low? Okay, yes, it is lighter. Very well, Wei Liang. High or low? Elastic limit need to be high. Yes, very well, Jinjie. Why? Big or high? Okay, elastic limit need to be high or big. Why? Why means one? Why you say the elastic limit must be high? Okay, Wei Liang, you don't say more than 40. Okay, 40 Newton. Okay, that is not acceptable in this answer. Never mention about the quantity. Just say high or low. Okay, means one say can support more weight. Okay, any other reason? Okay, any other reason? Yes, so it can withstand higher or greater force. Mean it can support more weight. Accepted. All right. Then talking about the strength. So how about the strength? High, low, or medium? Okay, elastic limit, Jinjie said to be able to return to original shape. Okay, accepted. Okay, so the strength has to be high. Okay, the strength need to be high. Okay, why? So you can say the cradle not break easily. Yes, strength is high. Or you can say it will be long lasting. Okay, or not break easily. Long lasting. Okay, so which one is a better choice? A, B, C, or D? So which one? So which one is it? So choose A, choose B, choose C, or choose D. So we choose, yes, we choose spring C. Okay, we choose spring C. So to get the 10 mark, okay, so how to explain? So you state all the characteristic for spring C. Or you can also state all explanation for spring C. So how we say, so how to write the explanation? It has low spring constant, low density, high elastic limit, and high strength. Or also you can mention about the explanation. So it gives high oscillation, light or low mass, reduced mass, withstand greater force, and not break easily. So both are accepted. Either you state the characteristic for C or you state all reason for characteristic of C. Okay, again here in the first point, the spring constant. Why we choose a spring with a low spring constant? Because remember class, what is the relationship between spring constant and stiffness? Okay, stiffness means the hardness of the spring. A spring with a high spring constant is a stiffer. Means the spring is stiffer or harder. So harder spring or stiffer spring not very suitable to make a cradle because very difficult for it to oscillate. Okay, because the spring is harder or stiffer. So it's not a good characteristic in order to make a cradle. Okay. So we choose a spring with a low force constant, so that it will be less stiff, less harder, so it can oscillate easily. That is the purpose of a cradle, to oscillate so the baby can sleep on it. All right. So are you clear with the first characteristic why we choose a spring with a low spring constant? Okay. Okay, so next question, question D. Okay, now we have diagram 3.2. It shows a graph of tension against stretch. Okay, tension means the force applied against a stretch. Stretch refers to the extension. So we have two types of spring here, P and Q. Okay, P and Q. So what is the question that follow? Okay, number one. Okay, which spring is harder? So which spring is harder, P or Q? Harder means stiffer. Okay, the spring is stiffer, harder. So which one, P or Q? What do you say, P or Q is harder? And then why you say so? If you say P, why? Why P is harder? If you say Q, state your reason why you choose Q. So which one is harder? Okay, remember when you have force extension graph, okay, the stiffness or the hardness is given by the gradient, the force constant. So a spring with a higher gradient or higher force constant show a harder spring. So answer is P. Yes, very well. Sorry, jawapan cikgu di sini silap. Supposed to be spring P. Okay, not spring Q. Okay, you please do the correction here. This is supposed to be spring Q, not spring P. Okay, cikgu silap type di sini, typing error. It's supposed to be P. Okay, I have corrected. Okay, answer is spring P. Why? So the reason is because it has a higher gradient or higher spring constant. Alright. Okay, so answer spring P, spring constant. Okay. Okay, now in 2 you have to calculate the work difference. of the spring as they are stretched to 8 centimeter. Okay, find the work different. Okay, the work different is represented by the elastic potential energy stored in the spring. Okay, when the spring is stretched or compressed. Okay, works refer to the amount of elastic potential energy of the spring when the spring is either stretched or compressed. So how to find this elastic potential energy? By calculating the area under the graph. Okay, remember for spring, if you are given a graph of force against extension, the gradient of the graph will give you the force constant. Okay, while the area under the graph will give you the elastic potential energy stored in the spring or the work done when stretching or compressing the spring. So how to do this? It say that the work difference, okay, when they are stretched at 8 centimeters. So you look at this graph, okay, when they are stretched at 8 centimeter, mean X is 8. So you look for P, when X is 8, the force applied is 4. So this is a triangle for P and this is for Q. Okay, so you can shade. Okay, you can shade the area involved for both P and Q at extension of 8 centimeter, and then you can minus. So this is for P, half multiplied by 4 multiplied by 0.08, extension in meter. Okay, in meter, 0.08 minus the work done for Q. So half multiplied by 2, okay, multiplied by 0.08 is the extension. So by this, the work difference is 0.08 joule. Okay, can support more force. I think this one relate to the previous question, right? Can support more force, support more weight. Okay, Wei Liang can support more weight. The force in the cradle refer to the weight of the baby. Okay, so class, by this, the work difference again 0.08 joule. Alright. Okay, so are you clear how to find the work difference? Again, work done or elastic potential energy stored in a spring can be determined from the area under the graph of force against extension of a spring. Okay. Okay, next we move to question 4. Okay, question 4 is on chapter 3. Okay, chapter 3, forces and pressure. So you are given two diagrams, 5.1 and 5.2. It shows a spring balance supporting metal block in two situations. And these two blocks are identical. Okay, compression balance in diagram 5.1 and 5.2 show the reading of the weight of an empty beaker and the weight of a beaker filled with water respectively. Okay, so in diagram 5.1, the beaker, it shows when the metal block is not yet immersed. Okay, the metal block is not yet immersed in the water. So the beaker is empty. While in diagram 5.2, once you immerse the metal block into the water, so there will be water come out, okay, from this end, from this eureka can, and it will be collected inside the beaker. So now you can see the beaker is containing water. All right. So what is the first question? What is the meaning of weight? What is weight? Anyone? What is the meaning of weight? Okay, do you remember anything about weight? You can share your answer. So weight refers to, very simple, two words only, gravitational force. Okay, weight is gravitational force. Alright, okay, and then B. Name the physical quantity that is represented by the reading of the spring balance. Okay, spring balance used to measure what? Okay, type your answer for B. Spring balance used to measure what? Name the physical quantity represented by the reading of the spring balance. Okay, spring balance measure what quantity? Okay, it measure what? It measure mass or it measure weight? Which one? Spring balance. Okay, so what do you say? Spring balance used to measure what? You don't say base quantity. It's a name the physical quantity. So name the physical quantity. So you must be specified which quantity. So which one? Force, weight, mass. Which one? This is spring balance. Okay, spring balance. Remember, spring balance is used to measure weight. Okay, spring balance is used to measure weight. For mass, what is the apparatus we use to measure mass? For mass, we can use mass balance or we can use triple beam balance. Remember, in the laboratory, to measure mass, we use mass balance or triple beam balance. So spring balance is used to measure weight. Okay, very good, Rafael Shafiq, 15. Okay, means one. Yes, it is mass. Okay. Sorry, it is weight. Weight. Okay, not mass. Okay, weight. Okay, second. Sorry, I show you the answer too fast for C. Okay, name the physics principle involved in this situation. Yuchin, it is weight. Okay. So what principle involved in this situation? So this is to do with Archimedes principle. Okay, Archimedes principle. Buoyancy. All right. So if you look at this diagram, so you know it is referred to Archimedes principle. Please spell correctly Archimedes principle. Okay. Okay, next. Okay, we go to question 5. Okay, very fast. Question 4 is just short. Okay, now question 5. This is again pressure. Okay, chapter 3. Forces and pressure. Okay, you can see diagram 3.1. A man is sitting on 800 nails. Okay, and he feel no pain at all, although the nail exerted the pressure on him. While diagram 3.2 shows the surface area of the tip of the nail. Okay. So if we zoom this diagram, so each of the nail has a tip with an area of 2 times 10 negative 7 meter squared. Okay, he is now sitting on a 800 nail. And the weight of the man is 500 Newton. Okay, first, what is the meaning of pressure? Pressure. Everyone, pressure refers to? Okay, what is the meaning of pressure? Okay, this also you're familiar with this question. We already answered it for so many times in the classes before. So pressure refers to, yes, force per unit area. The word unit must be mentioned every time. Force per unit area. Or you can say force acting on a unit of area, on a unit of surface area. Alright, so this is pressure. Force acted perpendicular to the per unit area. Exactly. Correct. Okay. Or by our, in simple way, we say force per unit area. The keyword is force and then per unit area. So all these four sentences is the keyword. Okay, force per unit area. Okay, very well, Rafael. Which school are you from? Can you identify yourself. Thank you for joining us today. Okay, now question B. Very simple. State the unit SI unit for pressure. Okay, pressure. SI unit for pressure. So what is a SI unit for pressure? Class. Okay, very well, Jingjian. Force per unit area. Okay, William also force per unit area. Okay, now B. What is a SI unit for pressure? Yes, it is measured in the unit of Newton per meter or Pascal. Okay, Pascal or Newton per meter square. Alright. Okay, now C, you have to calculate the pressure exerted produced by one nail in diagram 3.2. Yes, Pascal, Eugene. It is Pascal. Okay, how to calculate pressure exerted by one nail in diagram 3.2. So what is the formula to find pressure? So pressure is force divided by area. So just now we give the definition. Force per unit area. Okay, so what is the force applied here? So the force applied here refers to the weight of the man. So what is the weight of the man? 500 Newton. So what is the area for one nail? So this is the area for one nail. 2.0 times 10 negative 7. So when you do the substitution, will secure you your first mark, mark number 1. Okay, substitution on the correct value. Okay, then you solve. So by this, the pressure is 2.5 times 10 power of 9 Pascal, or 2.5 times 10 power of 9 Newton per meter square. This is your second mark, M2. Alright. So very simple, how to find pressure exerted by one nail. Okay, next. State two factors affect pressure. Very simple. Okay, betul ke jawapan William? 2 times 10 negative 7 multiply by 800. Why 800? Why multiply 800? They ask you for one nail. Okay, one nail. So kita cari satu sajalah. So the weight of the man divide by the area for one nail. That is the pressure exerted for one nail. Okay, D. Okay, are you clear about C, class? Okay, you have to read the question carefully, then only for you to do the calculation. Okay, now how about D? State two factors affect the pressure. So what factor affect pressure? Just now P is F divided by A. Okay, Jinjie said height and density. Okay, any other answer? State two factors affect the pressure. Any other answer? Jinjie said height and density. So others, what do you say? I give you the clue, the equation just now, P equal to F divided by A. Means on say base area. Okay, number 1 is the force or the weight applied. Okay, it will affect the pressure. Second, the surface area in contact. Okay, so these are the two factors affect the pressure. Force or the weight apply and also the surface area in contact. Okay, magnitude of force, area. Yes, very good. All right. So we go to question 6. Question 6. Again, we have chapter 3. Okay, chapter 3, 7.1. Okay, if you look at this diagram 7.1, directly it can bring you to what principle? Okay, so A1, name the principle involved in this hydraulic system. Okay, before that, we have 7.1 shows that hydraulic system of force F is exerted on the small piston. So you can see on the left side is a small piston where we apply the force at. And on the right side, we have a bigger or larger piston. Okay, first, name the principle involved in this hydraulic system. So what is the name of the principle? Yes, very well, means one. Pascal principle. Okay, Pascal principle. Okay, now compare pressure at point P and point Q. What can you say about the pressure? Are they the same or one is higher than the other one? Okay, what do you say? Pressure at point P and point Q. Okay, Waylon say they are the same. So let's check. Yes. So pressure at point P and point Q, they are the same or equal. Okay. Next. Okay, now we have diagram 7.2 show a hydraulic jack in a car service center. Means one, Q higher than P. Why do you say so? The pressure is the same. Okay, pressure is the same. The pressure exerted at P will be transmitted equally throughout the liquid. So the same amount of pressure will reach Q. Alright? Remember Pascal principle. What is the definition for Pascal principle? It says that in an enclosed system, okay, in an enclosed system, the pressure exerted, okay, will be transmitted equally throughout the liquid. So in every point, it will receive the same amount of pressure. Okay, now we go back to this question. Car jack. Okay, car jack is a device which is used to raise the car. Okay, when you want to change the tire, for example. Okay, so a force of 50 Newton is exerted on the small piston when the handle is pushed down. So you push down the handle with a force of 50 Newton. Okay, and the cross-sectional area of the small piston and the large piston is given 0.04 and 0.8 meter square respectively. Okay, so this is our diagram 7.2. Okay, a structure of a car jack. This is a handle connected to the small piston, and at this side is the large piston. Okay, the load here is your car. Okay. So what is the first question? Calculate the pressure exerted on the oil in the hydraulic jack. So how to find the pressure exerted on the oil? So again, what formula we are applying here? So we apply, before that, this is the given value. Okay, the given quantity F1, 50, A1 and A2. Okay, so how to find the pressure exerted? So we can use P equal F divided by A. F1 divided by A1 since we have both. Okay, they are given. So F1 is 50, A1 is 0.04. So by this, calculate for the pressure. So the pressure will be 1250 Pascal. Okay, 1250 Newton per meter square. Okay. And then second, calculate the force that the oil exerts on the large piston. Okay, now how much force produced on the large piston? Okay, so how to find this? So we can use this equation. Sama juga like the previous one. P equal to F1 divided by A1. So here P equal to F2 divided by A2. So we are finding for F2. So P is 1250. Area for the large piston is given 0.8. So by this, in F2, the amount of force produced is 1000 Newton. Okay, 1000 Newton. So do you remember one of the purpose of a hydraulic jack? or one of the purpose of a hydraulic system. We apply small forces in order to produce large forces at the output. Okay, we apply small forces at the input, and finally, a bigger or huge forces are produced in the large output. So that's why we also call this hydraulic system as a force multiplier. Okay, force multiplier. Apply small forces, in the end produce bigger forces at the output. Alright? Okay, next. We go to question 7. Okay, finish with the Pascal principle. Okay, now question 7. Okay, this is a question on heat. Okay, the data in table 11 shows a series of observation and record made by Halim of a melting process of an ice cube in a beaker on Bunsen burner. Okay, so this is the study which has been conducted. The first column shows the time and the observation, and the third shows the temperature. Initially, okay, at 0 second, the substance is exists in a state of ice, solid. Okay, temperature is 0. After 30 seconds, what happened? The ice cube is start melting. Still, the temperature is 0. Can mean the phase is changing, but the temperature is still constant at 0 degree Celsius. At 60 seconds, what happened? All ice cube has been changed, has been melt into liquid state, but the temperature is still 0. Okay, and after 250 seconds, now the water molecule move in a high speed. This is the observation, and the temperature is now at 50 degree Celsius. Okay. So what is the first question? Underline the correct answer in the sentence below. So heat energy to melt the ice cube from the above observation is obtained from the heat of the Bunsen burner, and okay, from where the heat come in this experiment? First, the heat is come from the Bunsen burner. Another one, the heat is coming from where? Is it from the ice itself or from the surrounding? From the surrounding air. So which one is your answer? From the ice itself or from the surrounding air? Okay, very well. Rafael Shafiq just now, 1000 Newton. Yes. So which one is your choice? The ice itself or from the surrounding air, class? Okay, so yes. Another one is coming from the surrounding air. Heat is coming from the Bunsen burner and the surrounding air. Okay, second. Name the physics quantity that is involved when ice cube change to water at constant temperature. Okay, what is the name of the physics quantity involved? Ice cube change from water, ice cube change into water at constant temperature. So if you follow my class on last Sunday, I am discussing about heat. You will answer. You can answer this very well. Okay. So what is the name of the physics quantity involved when the ice cube change into water at constant temperature? Means one say latent heat of fusion. Why the question mark is at the back? You don't feel confident? Yes, your answer is very right, very true, correct. Congratulations. Latent heat of fusion is the name of the physics quantity. Okay, third, it's not temperature. You read the question carefully. Name the physics quantity involved when ice cube change to water at constant temperature. So here, this question involves heat. Okay, mean the physics quantity is the heat. Okay, what is the name of the heat? So the name of the heat is latent heat of fusion. What is latent heat of fusion? Latent heat of fusion is the heat required to change the phase, okay, of a solid into liquid at constant temperature. or the other way around. The heat required to change the state of state of liquid into solid at constant temperature. Okay, next. Why temperature remain constant when ice melt into water? So before we answer this, I want to ask you, when ice melt into water, is heat absorbed or released? Ice melt into water, heat absorbed or released? Latent heat absorbed or latent heat released? Which one do you say? Ice melt into water. Involve absorption of latent heat of fusion or release of latent heat of fusion? Which one? It is absorb or release? Answer is absorb. Okay, absorb. Okay, ice melt into water, it absorbs latent heat of fusion, but the temperature is constant. Yes, Vinci, Wei Liang, Dylan, very well, absorbs, answer. Why the temperature constant even though heat is absorbed? Why? Can you tell why? Even though the heat is absorbed, but the temperature remain constant. So what is this heat used for? So this is because the heat is used to overcome, okay, the molecular forces of the ice. Or you can say the heat is used to overcome the forces of attraction between the ice molecule. Okay, yes, Jinjie. To break the bond. Energy is used to break the bond between molecule. Yes, Wei Liang, to break the bond between molecule. So by this, the kinetic energy of the molecule is not increasing. Okay, the kinetic energy is not increasing, so that's why the temperature does not increasing. Okay, that is the reason. Okay, number 4. Okay, if the previous question, okay, just now they give you 1 mark. Okay, they give you 1 mark, so you can mention the heat is used to overcome molecular bond or molecular attraction, molecular force. But how if this question allocate 2 marks? So if 2 marks, you add another one. So you can add another one, second point. So kinetic energy does not increase. Okay, second mark. Kinetic energy does not increase. So that's why temperature remain constant. Okay, number 4. Calculate the amount of energy absorbed by the ice to turn into 50 degrees Celsius of liquid. Okay, I give you a few minutes or a few seconds to deal with these questions. Okay, you are given specific latent heat of fusion of ice, 3.34 times 10⁵ joule per kg. And the specific heat capacity of the water is 4,200 joule per kilogram per degree Celsius. For how to find amount of energy absorbed. Okay, so first and foremost, what to do? How many process involved here? Ice turn into 50 degrees Celsius. Okay, Wei Liang say 2.525 kilojoule. Okay, how about the others? Have you find them? Okay, so remember to find heat. Okay, we are having two formula, MC theta. Q equal to MC theta. That one involve temperature change. Okay, another one we have Q equal to ML. Okay, latent heat. That one without temperature change. So for this situation, before we determine, okay, first you can do this changes of phase of substance. Initially, the ice is at 0 degrees Celsius, ice in a form of solid. Then it melts into liquid at constant temperature. So here, the process involves latent heat. So Q is given by ml. Okay, and then after that, the liquid at 0 degrees Celsius continue absorbing heat and the temperature increase to 50 degree Celsius. So here it involves MC theta. So how to find Q? So Q is ml plus MC theta. Okay, ml plus MC theta. Okay, so we do the substitution. Okay, this is the mass. Remember class, mass must be in kilogram. You know where this mass coming from, right? It was given in the table 0.0125. Okay, given 12.5 gram. So we convert into kg, 0.0125 kg. Okay, this is the latent heat of fusion. Okay, and MC theta, the mass, this is the specific heat capacity for water, and this is the temperature change. Okay, temperature change. 50 is the final, 0 is the initial temperature. So let's check your answer, Wei Liang. Macam tak betul Okay, so the correct value is 68,000 joule. Okay, 68,000 joule of heat energy. Anyone come up with this answer? Anyone get the same answer with me here? 68,000 joule. Okay, so I hope by showing you this chart, you are now clear how to face with this question. Okay, first you have to know the changes of phase involved. Okay, from there only we can determine, okay, what process involved, what type of heat involved. Okay. Next, question 8. Okay, question 8 again on heat. Okay, diagram 12.1 show a metal P at 100 degrees Celsius being placed in a beaker of water at 28 degrees Celsius. So you can highlight all this information. Yeah. Teacher, not 6. Am I calculated wrongly? Okay, we check again. How many zeros supposed to be there? Okay, I check it again. Okay, if wrong, then we can make a correction. Okay, 0.0125 multiplied by 3.34 times 10 power of 5. Okay, and then we plus with 0.0125 times 4200 times 50. Okay, very well, Vinci. Only only 20 there. 6800 joule. Okay, thank you for correcting me. Okay, so I do a correction here first. Okay, so it's supposed to be 6,800 joule only, not 68,000. All right. Okay. Okay, so I have corrected the value. So it is 6,800 joule. Okay, thank you for the correction, Vinci. Okay, class. Okay. Okay, so the final answer is 6,800 joule. Okay. Okay, next we go to question 8. Okay, the rest of you, I hope you also can get the correct answer, 6,800 for question 7. All right. Okay, now we back to diagram 12.1. Okay, we have metal P initially at 100 degrees Celsius being placed in a beaker. So we immerse P in a water of 28 degree Celsius. So after some time, thermal equilibrium state is achieved. Mass of metal P and water are given 0.4 and 0.2 kilogram respectively. All right. So diagram 12.2 shows to us the temperature against time graph of these two substances. Okay. So what is the question that follow? A1, again, definition. What is the meaning of thermal equilibrium? So what is thermal equilibrium, class? 1 mark. What is the meaning of thermal equilibrium? So what to say? What is thermal equilibrium? It is a situation in where two bodies in contact, okay, are at same temperature, where the net flow of heat between these two objects is zero. So the keyword is two bodies in contact, in thermal contact. Next, same temperature, net flow of heat zero. Okay, that is the keyword. Okay, two bodies in contact, same temperature, when net flow of heat between them is zero. Okay. Second, based on graph in diagram 12.2, what is the temperature when thermal equilibrium is achieved? Okay, let's take a look at this graph. So tell me, what is the temperature when thermal equilibrium is achieved? You can see this is how the temperature change. And here it shows the straight line graph. Okay, so by this, what can we say? What is the temperature for the thermal equilibrium? It is, yes, 40 degrees Celsius. 40 degrees Celsius. Okay, third question. What is the purpose of wrapping the beaker with a layer of cotton? Okay, why we wrap the beaker with cotton? For what? If you zoom in this diagram, okay, so the beaker is surrounded by cotton wool. Why? Yes, it is 40. Very well, Dylan means one. 40 degree Celsius. Okay, don't just say 40 degree Celsius. Okay, so now why this beaker is wrapped with cotton wool? Okay, means one say prevent heat loss to surrounding. So yes, to prevent heat loss to surrounding. Very good. Okay, this is the purpose. We can wrap either with cotton or any other insulator. Alright. Reduce heat release to surrounding. Okay, accepted. Okay, prevent heat loss to surrounding or reduce heat loss. Okay, now B1. Okay, calculate the specific heat capacity of metal P. Okay, when given the specific heat capacity of water is 4,200 joule per kilogram per degree Celsius. So you are given the mass for each. Okay, you are given the specific heat capacity for water. Now how to find specific heat capacity for metal P? So what equation we applies here? Okay, so how to find? See? So we can use this equation. Okay, M1 C1 theta 1 equal to M2 C2 theta 2. Okay, at this side, it represents P, the metal. And on the right side, it represents the water. Okay, this is show that the heat lost by metal P, the amount of heat lost by metal P equal to the amount of heat gained by the water. Okay, so this is the meaning of this equation. So we do the substitution. So this is the mass of the metal C1 we want to find. This is the temperature change in metal P. Initially, the temperature is 100. Finally, the temperature is 40 when thermal equilibrium occur. And for water, mass is 0.2. This is the specific heat capacity. And this is how the temperature change in water. Finally, the temperature is 40. Initially is 28. Okay, so please be careful when you play with a lot of these numbers. So C1 is 420 joule per kilogram per degree Celsius. Can you please check for my answer? Is it correct? 420. So C1 is the specific heat capacity for metal P. Okay, is it correct 420? Okay. Okay, after that, you have to state assumption you made in B1. Okay, what is the assumption we made when we are doing this solution? Okay, when we say M1 C1 theta 1 equal to M2 C2 theta 2, what assumption that we made here? Okay, correct, Barry. Thank you, Vinci. So what assumption we made here in B1? M1 C1 theta 1 equal to M2 C2 theta 2. It means that 100% of the heat released by the metal will be 100% absorbed by the water. Okay, so no heat loss to surrounding. We assume that no heat loss to the surrounding. That's why we assume that amount of heat released by the metal equal to the amount of heat absorbed by water. Yes, Vinci, very good. No heat loss to the surrounding. Okay, LOSS, LOST, nothing, no problem with that. All right. Okay, no heat loss to surrounding. Okay, then question 9 again, heat. Okay, question 9, heat. Now diagram 13 show a large pot with noodle being cooked in a lots of hot water. Okay, first question, what is the meaning of heat? Okay, what is heat? What is heat? Okay, so it is very simple. Heat is a form of energy. It's a form of energy, or enough to say energy. 1 mark. All right. Okay, second, why is the noodle being cooked in a large amount of hot water? Okay, why use a lot of hot water? Why not a little only? Okay, why we are using large amount of hot water when you are about to cook a noodle? So logically, so this is to ensure energy. Yes, means one. Energy, Waylun. Yes, energy. Okay, so why noodle cook in a large amount of hot water? Number 1, so that there will be a uniform distribution of heat to the entire pot. Okay, so heat will be distributed evenly, uniformly to the entire pot. And second, so more water means more heat will be supplied to the noodle. Okay, more water means more heat will be supplied to the noodle. So this is the 2 point. Heat distribute uniformly to the entire pot, and so that more heat is supplied by the water to the noodle. All right. Okay, next, B. Okay, now the hawker added 2 kilogram of water at 30 degrees Celsius to 9 kilogram of hot water at 95 degrees Celsius. So what is the final temperature when the water mixture achieves thermal equilibrium? Okay, so now there are two different temperature of water. Okay, he add 2 kg of water at 30 degree into 9 kilogram of water at 95 degree Celsius. So thermal contact occur between these two water. Water at 30 degrees Celsius having a thermal contact with water at 95 degrees Celsius. So after a while, okay, they will reach thermal equilibrium. Okay, where the final temperature will be the same or equal. So we want to find this final temperature. So how to find it? How to find the final temperature of these two water when they are at thermal equilibrium? So what equation we apply here? Okay, you can try to work on them and find the final temperature. So again, we apply this. M1 C1 theta 1 equal to M2 C2 theta 2. So on the left side is the water with lower temperature. Okay, the water at 30 degrees Celsius, okay, ini will gain heat. While the water with a higher temperature will lose heat. So you can place in either one. Okay, any of this position. Okay, so here I write, okay, this is the water at 30 degrees. So the mass is 2. So final temperature will be higher. So the temperature change is Tf minus 30. Okay. C is the same since they are both water. So I cancel C1 and C2 because they are the same. Okay. So the one that remain is M1 theta 1 equal M2 theta 2. Okay, and on the right side, this is the mass for the hot water, 9 kg. Initial temperature 95. So final temperature is Tf. Okay, final temperature will be Tf. Temperature will be dropped from 95 to Tf. So this is the temperature change. For the cold water, the final temperature will be higher. So the temperature change is Tf minus 30. So by this, what is Tf? Have you find Tf, the final temperature of both water at thermal equilibrium? So is this is this value correct? Can you check for me? 83.18 degree Celsius. Okay, so water at 30 degrees Celsius added with water at 95 degrees Celsius. Finally, after thermal equilibrium is achieved, so the final temperature of both will be at 83.18 degree Celsius. So again, is this value correct? 83.18. Can you check it for me? Yeah, 83.82 degree Celsius. Is it? Correct, I typed wrong. Okay, thank you, Min Swan. Okay, so answer is 83.18 degree Celsius. So I hope you are clear with how to find final temperature at thermal equilibrium. Okay, next. C. Okay, a hawker plans to buy a new slow cooker pot for cooking porridge. After the porridge is cooked, the porridge will be kept warm for longer period. So table 13.1 show the characteristic of two types of inner pot for a slow cooker with a mass of 2 kg. Okay, so he has two options, P or Q. Power for each is at 170 watt. And then this is the temperature change of the inner pot. Both are the same at 60 degrees Celsius. And time for temperature change, 10 minutes for P and 15 minutes for pot Q. Okay. So by this class, first calculate the specific heat capacity of the inner pot for each slow cooker. Mean you find C for both P and Q. Okay, so how to find this? So for P, okay, so this is the equation that we can use to find the specific heat capacity. Q equal mc theta. Okay, Q here. So how to where is the heat coming from? The heat is coming from the, okay, this is an electrical devices. Okay, the pot is an electrical devices. So electrical energy is given by PT. Okay, power multiply by time. So the heat supply by the pot equal to the heat absorbed, okay, by it. So we use PT equal to mc theta. Okay, so for P, this is the power. 180 watt is the power. Time of operation 10 minutes must be in second. So multiply by 60. Okay, and the mass is 2 kg. So we are finding for C. Temperature change is given in the table 60 degree Celsius. So by this, the specific heat capacity for pot P is 900 joule per kilogram per degree Celsius. Okay, same things goes for Q. Okay, so again, Q equal to MC theta and Q is represented by PT. Power multiplied by time of operation of the pot. Okay, so the power is 70 watt. Time of operation 15 minutes multiplied by 60 to convert into second. And the mass is 2 kg. So we are finding for C where the temperature change is 60 degree Celsius. So what is C? 525 joule per kilogram per degree Celsius. So this is how we determine the specific heat capacity for both pot P and Q. Okay, 900 for P, 525 for Q. Okay, again, you please check this answer for me. Okay, let's check for sure. 180 times 10 times 60 divide by 120. Yes, the first one is 900. Okay, and then second we have 70 times 15 times 60 divide with 120. So 5 to 5. Okay, so this is how we determine C for both. Are you clear, class? Okay. The important is the energy changes, conversion of energy. How to write Q in terms of electrical energy. So it is given by PT. Power multiplied by time of operation in second. Okay, next. So based on your answer in C1, which inner port is the most suitable? So kita nak pilih yang mana? Inner port P or inner port Q? So we choose inner port P. Why? Because inner port P has a high specific heat capacity. So the food will be slowly become cool. Okay, remember, as a material with high specific heat capacity, it will keep the heat in a longer period. Okay, since it releases heat slowly compared to an object with a lower specific heat capacity, it will release heat faster. So we choose P. So the food inside can be kept warm at a longer period. Alright, this is the reason. Okay, so I think we have come to the final question for today, and still it is to do with heat. Okay, so class, again, heat. Okay, now we have diagram 14. It shows a doctor use a thermometer to measure a body temperature of a girl. Okay, so what is the meaning of temperature? Okay, question 10. Last question for today. What is the meaning of temperature? Okay, we also have dealt with this question for so many times in the class before. What is the meaning of temperature? Yes, temperature is degree of hotness. Okay, degree of hotness of an object. Okay, degree of hotness. Okay, second, explain in terms of thermal equilibrium how the thermometer reads the body temperature of the girl. Okay, this question is 4 marks. Explain in terms of thermal equilibrium how the thermometer reads the body temperature of the girl. Okay, so first, what happened? We place the thermometer under the patient's tongue. So there is a thermal contact between the body and the thermometer. Okay, mark number 1. So second, okay, when thermal contact occurs, so what happened? Degree of hotness. Yes, very good. Okay, so when there is a thermal contact, what happens? Heat will be transferred. Okay, heat transfer more from the body to the thermometer. Okay. And next, what happened? After a few while, thermal equilibrium will be achieved. Okay, where now the net flow of heat is zero. Okay, point number 3, thermal equilibrium achieved. You can add net flow of heat is zero. So by this, temperature or the reading of the thermometer will show the temperature of the patient's body. Okay, so this is how we explain in terms of thermal equilibrium. Point 1, thermal contact occur. Second, heat is transferred. Third, thermal equilibrium achieved. And you can add here, net flow of heat is zero. And finally, we say a reading of thermometer shows temperature of patient's body. All right. Okay, question C. Okay, now we have an uncalibrated thermometer. Okay, remember, even though the thermometer is uncalibrated, but still it can be used. Uncalibrated means it doesn't have any scale on it. Empty, no scale on it. Still, we can use the thermometer to measure temperature of substance. How? Okay. So what we have here, not calibrated, has a mercury column of length 5 centimeter when the temperature is 0 degrees Celsius, and 25 centimeter when the temperature is 100 degrees Celsius. And the mercury column is 12 centimeter when we put in liquid X. Okay, so it means that this uncalibrated thermometer, we immerse in a ice cube of 0 degrees Celsius. The length of the mercury column is 5 centimeter. So actually, this is the low fixed point of the thermometer. Okay, and then we immerse it into steam, 100 degrees Celsius. So the reading expand to 25 centimeter. The length of the column is now 25 centimeter. So this is called as the high fixed point. So we have low fixed point, L0, and high fixed point, L100. Okay, and then we bring this thermometer, we immerse into liquid X, which we want to know the temperature. So now the length is 12 centimeter. So this is called as L theta. Okay, so how to find the temperature? We apply this formula. Okay, I would like to remind you, this formula is not included in the formula list for paper 1 and paper 2. Okay, so theta is the temperature we are looking for. L theta is the length of the mercury column in liquid X minus L0, the length of the mercury column in the low fixed point, okay, which is 5 centimeter. Divide L100, the length of the mercury column in a high fixed point at 100 degrees Celsius, which is 25 cm, minus L0 again. So multiply by 100. Okay, so this is the substitution. 12 minus 5 divide 25 minus 5. Okay, L theta is 12 here. 5 is L0. Okay, L100 is 25 and L0 is 5. So multiply by 100. So by this, we can find the temperature of liquid X is 35 degrees Celsius. See, still we can use it even though it is uncalibrated. All right. Okay. Next, determine the temperature of liquid X in Kelvin. Okay, now the temperature is 35 degrees Celsius. How to convert degrees Celsius into Kelvin, class? So this is very easy. So theta is in Kelvin is 35 plus 273. So which mean in Kelvin is 308 Kelvin. Okay, 2 marks, 308 Kelvin. Okay, third, state a reason why mercury is used in a thermometer. Why always choose mercury to be used? as a liquid in a liquid in glass thermometer. What is the advantages of using mercury? Okay, 1 mark. Okay, 1 mark, but actually you can write more than one answer. There's a lot of options you can write here. State a reason why mercury is used in a thermometer. Can you state one of the reason? So what are those reasons? Okay, number one, mercury is opaque. Okay, opaque. So can be seen easily. You can read easily. Okay, then expand uniformly, high boiling point. Okay, second, it is a good heat conductor. Okay, opaque is there. Second, high boiling point. Okay, yes, Wei Liang, high boiling point. Okay, next, uniform expansion. Expand uniformly. Very good, means one. Okay, it expand and contract uniformly. Okay, and you can also say it does not stick to the glass wall of the thermometer. So it doesn't wet the glass wall of the thermometer, so easily for us to see the reading. So these are the 5 options you can state on the reason why using mercury in a thermometer. All right. Okay, we come to the last question, long essay, question D. Now you are given 4 thermometer. It is actually 4 thermometer, A, B, C, and D. And they give you 4 characteristics. The liquid used, we have mercury, another one is alcohol. Glass wall bulb, we have 2 options, thin or thick. And then diameter of capillary tube, we have 2 options, big or small. And then the length of the thermometer, better to be long or better to be short. So which one? So a research project carried out weather of a region surrounding temperature between negative 35 to 45 degree Celsius. Okay. Thermometer is an equipment to be taken for the research project. As a researcher, you are required to determine the most suitable thermometer to be taken with as one of item of the equipment. Okay, we have to study the characteristic on these 4 aspects. Okay, explain the suitability of the aspect. Justify your choice. Okay, justify your choice. So which one? So we go back. Okay, we have 4 thermometer here. Okay, so which one did you say for each aspects? Okay, so first, as usual, we can build our table of characteristic and explanation. Okay, first, the liquid use. Mercury or alcohol, which one is your choice? Mercury or alcohol? Okay, what do you say, the liquid use, mercury or alcohol? Anyone choose mercury? Anyone choose alcohol? So which one? Which one do you say? Mercury or alcohol, class? So we choose. So we choose mercury. Okay, we choose a liquid of mercury. Okay, mercury. Why choose mercury? Okay, mercury. You can write any of the characteristic earlier before one of those 5. Here it gives uniform expansion. Okay, you can keep high boiling point or high range of temperature, or you can give it doesn't wet or opaque, and any one of the 5 characteristic in the previous questions. Okay, glass wall bulb. Okay, glass wall bulb, thin or thick? What do you say? The glass wall bulb, thin or thick? What is the choices they give just now? Okay, thin or thick? Okay, so which one? Thin or thick? So we choose a glass wall bulb which is thin. Okay, thin. Why thin? So it will be more sensitive, high sensitivity. Okay, the reason is high sensitivity. So able to detect changes in temperature. Now diameter of capillary tube. Need to be big or small. The diameter of the capillary tube. The diameter of the capillary tube is at the center. Okay. So which one? Big or small? Diameter of capillary tube. So we choose a small. Okay. Small capillary tube. Again, to give you a high sensitivity of thermometer. Okay, while about the thermometer, long or short. So here it say long. Why? So it can measure wider range of temperature reading. Okay, wider range of temperature reading. So which one is a better choice? A, B, C or D? So you can choose which thermometer. It uses mercury, it has thin glass wall bulb, small diameter of capillary tube, and it has a long column. So we choose thermometer C. Okay, is it thermometer C? Okay, and finally you write all the characteristic or explanation for C. It uses mercury, thin glass wall bulb, small diameter, length, it is long. Or you can say it has uniform expansion, high sensitivity, and measure wide range of temperature reading. Okay, so class, so how do you find this module? Okay, actually, where did I get this module from? This is a module for Terengganu. Okay, a module score A plus for Terengganu. You know that Terengganu is always on top. Okay, every year in SPM. So their model is a very good in quality. So that's why I want you to try all of these questions. Okay, some of the question is quite tough, but the quality is also very good. And also these are the topics that most of the state focusing on for SPM this year. Okay, so if you have free time, you can refer back to this module again and try to understand all the concept and application applies in all these questions. So let's say in the future or in the real SPM, you are deal with the same question. So I hope you know how to solve them well. Okay, so I guess that's all for today. Again, as usual, you can go back to this video to jot down your name and your class for your attendance. And you can refer back to this video anytime if needed. Okay, I will post the full answer in my Telegram channel, but actually some of the answer is not correct, especially the calculation. That's why I made some correction here, so you can go back and check for them. Okay, the real answer, some of them are not correct. Okay, the calculation and some of the reason for the essay question. So I have made a final check on them before I share to you the complete answer here. And then again, please be aware with the correction I do just now in some of these questions. So I hope this will help you for your preparation. So in this Wednesday, we will proceed with the second module, module 2. I will post the question earlier before we discuss it on Wednesday. So again, you can try on them first. Okay, I prefer you to try them first, then only we discuss the answer on the next lesson on Wednesday. So by this, you can measure, okay, how much do you prepare for this and that topics. If possible, you try to do on your own. And then if you cannot solve them, then you can refer to any references or you can ask me as well. Okay, so this is how our revision goes. And I hope so far all the questions we have discussed, it will benefit you in the future, increase your understanding on mastering all topics in this physics. Okay, so I guess that's all for today. Again, thank you very much for your time. Thank you very much for your effort. So have a pleasant day ahead and see you again next Wednesday. Okay, if there is any problem arise, you can always reach me in Telegram or WhatsApp or WeChat or whatever. Okay, again, thank you very much for your effort. See you again soon. Bye. Thank you for participating.